Hello, this is Jim Shorkey. This is STA 2023, and this is also Chapter 2, Displaying and Describing Categorical Data. So the three rules of data analysis are make a picture, and then make a picture. So let's walk through these three rules. So the first one, or the first reason why you should make a picture, is it's going to help you think clearly about the patterns and the relationships in the data. It's going to be easier if you have a well-constructed picture to see these relationships than it is to see them just in a table of numbers. So the picture is going to help things jump out at you. The second reason is that a well-designed display is also going to show important features and patterns in your data, such as extraordinary data values or maybe unexpected patterns. And an extraordinary data value may be what we call an outlier. And we're going to talk more about those later in the class. And the third reason is it's also the best way to help you tell others about the data. You can actually let them see these patterns in the extraordinary data and these relationships and trends and so forth that you wouldn't necessarily, like I said before, be able to see in just a grid of numbers. A graph of your data should be easy to understand, and it should represent the data honestly. And the best way to do that is to make sure that you label all of the axes clearly with the name of the variable and the units. Also have easy to read numeric scales. Use a key if you have any colors or special characters in your graph. Also a title or a caption that summarizes what the graph displays and what story it's telling the reader. So the area principle is a fundamental principle which says that the area occupied by a part of a graph should correspond to the magnitude of the value it represents. Well, what does that mean? Well, let's look at a couple of examples here. The chart on the left, that's a poor representation, and what this is measuring are the number of visitors that are going to a website that sells shoes and where they're coming from. So we can see by looking at the chart on the left that obviously the majority of the visitors are coming from Google, and then the next one down are direct traffic. But what this doesn't tell us is, well, how many visitors are coming from Google, and how many more are coming from Google than direct or any of the other traffic sources that are on there. And the Google shoe is very disproportionate in size to the remainder of the shoe. So obviously we can see Google's sending us the most traffic, but how much more? Okay, so it's a little misleading. If we look at the bar chart on the right, that's a better representation. We've got axes that are clearly labeled. We've got a simple bar. We don't have anything fancy like a shoe that can kind of give us a disproportionate picture of what's really happening. And we can see that, okay, Google is sending about 50,000 visitors. Direct is sending, it looks like a little bit more than 20,000. Yahoo is a little bit less than 10,000. So we can look at it and actually have some perspective and context of the website traffic. So next we have frequency tables and relative frequency tables. So a frequency table is a list of categories and how many cases belong to each one. A relative frequency table displays percentages or proportions rather than the counts in each category. So let's look at the table on the left. The table on the left is a frequency table, and this table represents a count of hotel bookings on a website and where that traffic came from to complete that booking. So for this particular month, there was a total of 2,366 bookings, and Trivago was responsible for 797 of those bookings. GoSeek was responsible for 551 of those bookings, and so forth. So it's an actual count. So we know on our hotel booking site, the traffic that Trivago sent over to our site resulted in 797 bookings. Okay? If we look at the table on the right, that's a relative frequency table. And we can see that Trivago had 33.7% of the bookings in that month. So the 797 of the 2,366 is 33.7%. GoSeek had 23.3%, and so forth. So the frequency table gives us an actual count, and the relative frequency table gives us a percentage in order to how that count divided by the total. That's what it represents. So this slide shows us bar charts of the same data that we were looking at on the previous slide. And the bar chart on the left is the count of bookings for the month. So that would be a bar chart based off of the frequency table, it's the actual counts. And the bar chart on the right is based off of the relative frequency table, where it shows the percentages. So you can see that we got an axis there of percentage. On the relative frequency, we've got our marketing channels across the bottom, the horizontal axis. We look over at the count of bookings. We have the same thing there. We've got our vertical axis on the left that gives us our counts, and our horizontal axis across the bottom gives us our marketing channel. So another way of displaying categorical data is by using a pie chart. And a pie chart shows how a whole group breaks into several categories. The circle is sliced into pieces whose sizes are proportional to the fraction of the whole in each category. So if we look at the pie chart on the left, that is our count of bookings for the month. We have each slice of pie is a different color, so you can tell them apart. It's also labeled with the marketing channel and the count of bookings for that marketing channel. The pie chart on the left is the percent of bookings for the month. Once again, we have our slices there in different colors, so they're easy to recognize. And it lists the marketing channel and then also has the percentage of bookings that that channel was responsible for the month. So one thing that you should do is think about your data before you draw. Okay, you want to make sure that the data is appropriate to display and what's the best way to display it. I've seen some pie charts where there were so many categories, or there were categories that were so small that you had these tiny little slivers of pie in the pie chart, and it was really difficult to determine what is it you're trying to tell me, what's the story that you're trying to tell me. So remember, you always want to be clear and concise. The other thing that you want to think about is the categorical data condition. Okay, the data counts or percentages should not be overlapping, which means that you should not have a record that falls into more than one category. Okay, those should be mutually exclusive. Okay, you don't want a data point that's going to be in category 1 and in category 2. Your data point is either in category 1 or it's in category 2, not in both. So the next thing we're going to talk about are contingency tables. And this is an example below here. It has 2 rows and 5 columns, and it shows the results of a random sample of 2,200 adults classified by gender and their favorite way to eat ice cream. So each cell of this contingency table gives us a marginal distribution. Okay, so looking at the table, we can see that 300 of the males surveyed prefer to eat ice cream from a cone. And we can also see that 180 of the females prefer to eat ice cream in a sundae. So we'll continue with this contingency table that we were looking at on the last slide. And the nice thing about the contingency tables is it gives you an opportunity to look at the data from different ways, different angles of looking at it. So for example, what percentage of those sampled who prefer their ice cream from a cone are male? Okay, so we want to calculate a percentage, but the question becomes, well, percentage of what? Okay, so to answer that question, if we look at the column that's labeled cone, we can see there were a total of 635 people from our sample that prefer eating ice cream from a cone. Now the question is, what percentage of those are male? So we know that 300 of the males preferred eating their ice cream from a cone. So to get that percentage, we divide 300 by 635. That gives us 47.2%. The next question, what percentage of all people sampled prefer their ice cream from a cone? Okay, so in that case, we're talking about all of the people who were sampled, the whole 2,200 people that were sampled. Of those 2,200 people, 635 preferred eating their ice cream from a cone. So we take 635, divide it by 2,200, and that gives us 28.9%. Or we could answer the question, what percentage of males who were sampled prefer to eat their ice cream from a cone? Okay, well, if we look across our male row, we can see there were a total of 1,200 males sampled. 300 of those preferred eating their ice cream from a cone, so 300 divided by 1,200 gives us 25%. So once again, this contingency table gives us the opportunity to look at data from different ways. We can look at it as a total of the whole population, as a column total, or as a row total. So the next thing I want to talk about is a conditional distribution. So a conditional distribution shows the distribution on one variable for a subgroup of individuals that satisfy a condition on the other variable. So we're going to look at this contingency table again, and we're going to do a conditional distribution. So how do the conditional distributions of eating ice cream from a cup differ for males and females? So what we're going to do is we're going to look at the group of those sampled who preferred eating ice cream from a cup and determine what percentage of them were male and what percentage were female. So we're going to look at the column that's labeled cup, and we had a total of 1,002 people who preferred eating ice cream from a cup. 592 of those are male, 410 of those are female. So we take the 592, divide by 1,002, that gives us 59.1% of the males prefer eating ice cream from a cup. And for females, it's the 410 divided by 1,002, which gives us 40.9%. So we're looking for the distribution conditional, in this case, conditional on the method preferred being a cup. So you could do that for cone, sundae, anything else, any other contingency table that you have, you could get a conditional distribution. You're just looking at one variable conditional on another variable.